Let's have a go at the following integral. So how are we going to find this one here? Now, what we need to notice is that there's a big disconnect in the power from this one to the numerator. So a substitution is unlikely to help me. A fraction, well, what kind of fraction is here? It's actually disguised. There is a fraction of 4 over x plus 1, x minus 1. Now, why is this helpful to see this? Well, when we've got fractions where we have a product in the denominator like this, partial fractions can help make the question into something that we can answer. Partial fractions says that for a fraction of 4 over x plus 1, x minus 1, there must be a way of writing this such that we have some constant over the first value plus some constant over the second value. Why is this good? Well, when we want to integrate the whole thing, we can sort of integrate them one at a time. And this is going to have something to do with natural log. So let's find our a and our b values before we go any further. So a good next step would be the following identity. So 4 is going to be equivalent to a times x minus 1 plus b times x plus 1. Here we might as well use the substituting numbers approach because it's much quicker. So if you have x as 1, what does that make happen? It means that 4 will be equal to 2b. In other words, b is 2. What else will happen? Well, if you use x as minus 1, b will sort of disappear if you like, and we'll get 4 is equal to, well, that'd be minus 1 minus 1, so it'd be minus 2a. So a will be minus 2. Now, we can put these values in and we can use them. So a has to go there, and b has to go like here. Okay, it's important that the right numbers match up with the right denominators. So what we now need to do is we need to integrate, and there's lots of different ways of kind of working with this, but we need to integrate minus 2 over x plus 1, and we need to also integrate 2 over x minus 1. So you might want to just try the sort of intelligent guess and adjust method. So if we do the first one, this is going to have something to do with the natural log of x plus 1. Now, if you differentiate inside for the chain rule to check your answer, x differentiates to 1. So there's no sort of chain that I need to be careful of. Well, how do I deal with the minus 2? Just leave it where it is. Leave it on the outside. There's nothing else extra in this question for us to adjust or change. That's it. The other one is very much the same. Okay, so you could do 2 natural log of x minus 1 plus c as your answer. Notice that I am assuming for this that you don't need to do any extra manipulation, because there is a way that you can move your powers up here, and because of the addition rule, you would be able to combine the logs. So for our integral today, when you have a difference of 2 squares, watch out, because it's really masking the fact that you've got a partial fraction situation. A partial fraction situation is when we said that something in this format can be broken up, and when it's broken up, we often have natural logs. They're a bit of a clue if you've got a show that question.